let f of x equal x squared plus 7x plus 9. Does an inverse function exist for the entire domain of the function? Find the inverse of this function. So what I have done is I've gone ahead and typed it over here in the right side of the screen into Desmos so that I could just quickly get some good points to graph. So let's pick out these 3 points. Negative 3.5, negative 3.25. So I'm going to estimate on my graph where that would be. So negative 3.5, negative 3.25 looks like it's about right there. Negative 5.3 looks like a 0, so 1, 2, 3, 4, 5, and a little bit further to the left. And then negative 1.7 approximately. So then I get a good sketch of my graph with 3 key points. Now what I'm going to do is write those down in my table. So I have f of x is my original function. And let's just jot down negative 5.3, 0, negative 1.7, 0, and negative 3.5, negative 3.25. So for the inverse function, we could switch x and y and plot them. So if we say that would become zero, negative 5.3, 0, negative 1.7, and negative 3.25, negative 3.5. And plot them, let's look what happens. So 0, negative 5.3 would go down 5.3 from the origin. So 1, 2, 3, 4, 5.3 down there. 0, negative 1.7 goes almost to 2 boxes below. And then negative 3.5, negative 3.25, negative 3.5 is really close to that other point for our red graph's vertex, our original vertex. All right, so then it says, does an inverse function exist for the entire domain of the function? The answer would be no, because this entire domain creates a function in the blue, our inverse function, which is not a function because it does not pass the vertical line test, as you can see. So what we could do is limit the domain of our original function to create an inverse function that would be a function. So what I'm going to do is just pick half of that original function, and it doesn't matter which half you choose. But if I were to only pick half, so like either this side or that side, then that would be okay. But up to 0 is all I could do, or down to 0, whichever way you think about it. So if let's just grab another point, like 0, 9 was a point. I don't know if that'll fit on our graph. But if we limit the domain to where it's only that part of our graph, then our function would be okay as an inverse. Think about that same idea we've talked about before, where it reflects over the line y equals x. So let me show you something. If we were to graph only this first half of our red original function, and that reflected over the line y equals x, then it would only be the lower half of that sideways blue inverse parabola, and that would be okay. And now you can think of it the other way. So if I were to graph the other portion of our original function, if I did not limit the domain, then it would create a function that's an inverse that is not a function because it doesn't pass the vertical line test. So you would limit your domain. Let's write this down. Let's just make it simple. Limit the domain so that it goes from negative infinity up to, this was negative 3.5, or, so let's say negative infinity to negative 3.5 would all be okay. Or you could go from negative 3.5 to positive infinity, and that would be okay. But you can't have both of those parts of your domain and end up with an inverse that is a function. You can only have the first half or the second half so that the blue inverse function is a function. In other words, it passes the vertical line test. So that's it for example 8.